Hello friends, welcome back. So till now we have seen that how we can do the sentiment analysis, how we can basically prepare a machine learning model which can be trained on us for the sentiment analysis. And we have trained our model on two columns. One was text and the other was sentiment. But in the real life, it may be that uh, your data is multifaceted. Okay, it has multiple columns, and in fact, having multiple columns, having multiple values indicating a particular sentiment for the training data, that will be really useful if you are training your machine learning model. So let me show you that training data that I'm using here. So this will be the training data. There are five columns: text, sentiment, explanation, specific phrase or word, and the category. For example, on the first line, you can see, thank you for your prompt response. This is the text, and the sentiment is positive. Here it's like a specific, here it's like explanation why I have given it as one, a positive review, right? The reason is positive review. It is a positive review. That is why we have given it like positive review. And that is why we have given it like one. And then it's like a specific phrase or word. What a specific phrase or word identifies this particular sentence to be a positive review? It's thank you. You can see there is a thank you phrase here. So a specific phrase or word that is making it as a positive sentiment that is also explained, that is also added here as the last column, which is the category column. Okay, so you can consider that these are the four variables: text, explanation, a specific word or phrase, and then we have category. So you and then the sentiment is the the value, right? The sentiment is the value which we want to predict. So basically, sentiment is something which we want to predict. So sentiment is like y in a mathematical linear equation. You write like y is equal to a1x plus b1y plus c1z, something like that. You might have written. So it's a simple linear equation with number of variables, right? So you can see that our sentiment is y, and this text, explanation, specific phrase or word, and the category, these are the different uh, you know variables. So you can say that sentiment is a function of these four variables, which is like text, explanation, a specific phrase or word, and the category, right? So sentiment is y, and these are the various variables, and sentiment is just the function of these: text, explanation, and these two remaining variables, right? So it's like a function. Sentiment is a function of these four variables. And similarly, you can see the other examples, just like here, your email was really helpful. So it is like positive review, and helpful was the specific word or phrase which identified it as a positive review. And then the category is assistance, right? So you can see that these specific, categories, they are really helping here, our machine learning model to identify the tone, right? So identify the sentiment, right? So this is really a more useful data compared to the previous example that we have seen. Okay, so now let us see our piece of code. I will share this piece of code in the comment section, and also I will share this training data with you as well in the one of the comment section. Okay, so there will be two comments, one for this training data, and the other one will be for the code. Okay, so in this piece of code, you can see there are five new things: accuracy score, the classification report, the classification report, the confusion matrix, the column transformer, and the pipeline. These are the five new things that you can see here in your code. And rest of the things, they like sklearn, TF-IDF vectorizer, train test, split, and then multinomial NB. These all I have used, just like in the previous example. So now let us see what we should do. First step is reading the CSV file, which is the same file that I just showed you. So we are loading it here. And after that, we are preparing the text columns, right? Those features which are deciding the sentiment. Okay, so text, explanation, a specific phrase, word, and the category, these are the four variables. So these will be the text columns. If you have to add more columns, you can add them. But if you don't want to do, then in that case, these are fine. It's up to you. If you want to, just rephrase your training data, you can do, right? I'm just telling you one example, right? Now let us see this example: split data into training and testing sets. So here it's like x underscore train x test. So I have already explained this train test script. So first argument is all the text, feature columns, right? So this is df text underscore column. So this is data frame for these text columns. And then the next is df sentiment. Okay. And then we have test size. I want to give the test size as 20% of the complete data. And then we have the random state 42, which we have already explained in the previous video. Now come to the two new things. One is pipeline and the other one is the column transformer. Okay, so let us see what we do with the help of the pipeline and the column transformer functions. What does they do? So here is the information about the pipeline object. So basically pipeline object, as you can see, I have already written here as a note. So it's a scikit-learn library part. So the pipeline class is a utility class that allows you to chain multiple data processing steps together, creating a workflow or pipeline, right? So you can see that in this example, TF-IDF vectorizer, I have used all in, inside the column transformer. But earlier, if we go with the previous example, then for each of the column, you have to do it separately, right? But if you want to make it as a pipeline where one step is performed after the other, then in that case, you can use the pipeline. This class object, you can use this class, this utility class, which is known as the pipeline, right? So in this one, you can see that we have called like column transformer function. So first, let's complete the pipeline object. So there is some basic information related to the pipeline object. So the pipeline object consists of a sequence of steps where each step is a tuple. Tuple means there are two arguments, right? One is vectorizer, we can give any name, and the other one is the function, the transformation function. So since we are using the column transformer, so we have given the name as column transformer, right? So you need two things, step name and the transformation object. So column transformer is the object, and the first one is the name of the step. And then we have this thing like in this example that you can see, there are two things. One is this step, this complete step we have where we have, TF-IDF vectorizer for all the four columns added. And we have used the stop word from the English language so that we can remove all the stop words from the English language. Okay. And we have done this TF-IDF vectorization on four columns. This TF-IDF vectorizer thing I have already explained. This is term frequency, inverse document frequency thing. So that I have already explained to you. So you can see like text, explanation, specific phrase word, all these things, we are applying the TF-IDF vectorizer. And then the second argument is, second object is multinomial NB. We have already discussed about the Naive Bayes classifier and multinomial NB in the previous videos. So I'm not going to explain them again. So our pipeline consists of two steps. So basically all the arguments that you are able to see, they can be any number of arguments. So they are not actually known as argument. That's why, right? That is why we don't call them the arguments. We call them the steps. So here also you can see like this pipeline consists of two steps. I have used this word steps, right? Because it is basically the step. So now let us see some more information regarding the pipeline. One is the benefit of using the pipeline. It simplifies your workflow. It reduces code duplication. It improves readability, and it does the automatic handling of intermediate data. Okay, so this is more effective method. This class is basically pipeline is a class which is more effective class, which is really useful when you are training your data, when you're preparing your data for the training. Okay, so here is the pipeline.fit. What does it do? You can see that after that we have called this pipeline.fit method. So we are basically training on the training data. Okay, we are training it on the training data. This is the training data. 80% of the training data that our code has already identified. This 80% of the training data will be trained, will be fitted, is using this pipeline. So pipeline is using is doing the learning here, is helping machine to learn here the things. Okay, so the x underscore train, which is the set of features for the training object, set of features. What are those features? Text, explanation, a specific phrase word, and the category. These are the four columns which are the part of this x underscore train. And then y underscore train, this is the other argument, which is basically the function of these four variables. So this is just fitting all the things, right? And when we come to the prediction for the test data, then we don't need to pass the training data, because you have to just predict based on the test data. You have to find out the y test. So you can see that only one argument is passed to the predict method, because you only have to give the x value, only the feature values. The real value, the sentiment value should come here as a prediction, so that you can evaluate whether the output is accurate or not, whether the machine learning model is accurate enough or not, right? So this fit method is applied on the training data. Since we are applying it on the training data, so we also need to pass the training value, I mean the value as well, the y value, the sentiment value as well, so that it can understand that uh, how the predicted value is dependent on these four variables. But here you cannot do that. You can simply pass the features here, and then after that you can simply find out the predicted value here, right? So let us understand rest of the things here. So here we have already explained it. Whatever I have explained you, that has been written here. When you call pipeline.predict, the pipeline will apply the vectorizer step to x underscore test, pass the transform data to the CLF step, make predictions using the trained CLF step, and there are certain common use cases here. One is text classification, other one is image classification, the other one is regression task. Okay, so these are the different common use cases. In case of image classification as well, and in case of regression task as well, the pipeline should be used. So we will, as soon as we will move into the course ahead, then you will be able to understand these text classification, image classification, and the regression tasks. Okay, so this is all about the pipeline. Now let us see what is specific about the column transformer. It is very easy. Column transformer is a utility class in the scikit-learn library that allows you to apply different transformations to different columns of your data. It's very simple. We are applying the different transformations onto the different columns, right? Like we are applying TF IDF vectorizer thing on the different columns, right? So we are using this thing for separate columns. So in the code that I have written here, in this code, what does it do? It separate the text columns, like all these four columns, from the rest of the data. Okay, it will separate, like if it is working on the text, then it will separate out rest of the columns. If it is working on the explanation, then it will separate out rest of the things like text, specific phrase word, and the category. So basically, it separates the text columns, individual text columns, from the rest of the data, and then train it. Then do the TF-IDF vectorization. And then it applies the TF-IDF vectorization to each text column individually. Okay, that I have already explained to you. So individually it applies. Okay, so it separates the column from the rest of the data, and then applies the TF-IDF vectorization to each text column individually. Okay, so we will run this piece of code in the next video, after explaining this accuracy score, classification report, and the confusion matrix. What are they? We are going to discuss all about them. So I hope you are understanding these concepts, because this is a different kind of series. This is a different kind of playlist I'm preparing, because I'm not telling you in this playlist like what is machine learning. I'm not telling you about the mathematical concepts. We are learning all these concepts related to machine learning with the help of the examples, with the help of the sample projects. So be with me, and like, share, subscribe, and have a nice day, and bye bye. We'll meet you soon on the next video. Thank you.